Right, we are plunging straight into the ultimate speedrun challenge for Cambridge IGCSE Physics 0625. In this explainer, we're completely skipping the fluff and zooming directly into the high-mark exam strategy that literally separates average students from the absolute top-tier achievers. We're going to solve a high-value problem faster than most ordinary students even read it. Because by the end of this, you won't just understand numbers, units, and significant figures. You're going to possess the exact framework to completely bulletproof your answers against the examiner's red pen.
So look closely at this massive zero. This isn't just some random placeholder. This is the exact number of marks an examiner is going to award you for a perfectly calculated, beautifully mathematically sound answer that just happens to be missing one tiny, crucial unit. No joke. You can do absolutely all the heavy lifting, remember the hardest equations in the syllabus, punch the exact right numbers into your calculator, and still get a big, fat zero.
And that brings us to a massive grade boundary risk. The stakes here are incredibly high, guys. Every single year, students drop an entire grade boundary. And it's not because they don't understand the physics, but because they are just bleeding easy method marks. We're talking about rounding too early in a multi-step calculation, or, forgetting a simple prefix like milli or kilo. These aren't just minor slip-ups. In the eyes of the Cambridge examiners, these are fatal errors that completely destroy the validity of your scientific data.
To really see this in action, check out this classic two-student duel. On the left, we've got an ordinary, flawed revision attempt. The student wrote 12.34. They probably saw this massive long string of decimals on their calculator and just chopped it off randomly. But notice what's missing. There's literally no unit. It is completely naked data. Now, look on the right. Here we have an elite, top-band answer, 12.3 meters per second. This student actually understood the precision of their instrument, they rounded to the correct significant figures, and they locked in the exact unit. The student on the left gets 0 marks. The student on the right, full method and accuracy marks. It is a game changer.
And that leads us straight into the most painful traps laid out by the practical data coach. Missing units and rounding too early? That's really just the beginning. Examiners are actively hunting for vague explanations. They're looking for graph axis errors where your scale is nonlinear or just poorly labeled. They'll ping you for weak practical improvements, identifying the totally wrong variables, or drawing these grand conclusions that simply aren't supported by the data you actually gathered. Ordinary revision completely fails to prepare you for this stuff, because ordinary revision is just memorizing formulas. We need a real strategy.
So in just a moment, I'm going to show you the exact examiner clue hidden in the data that changes your answer completely. If you miss it, your entire calculation just collapses. But, and this is a big but, before you can even spot that clue, you need the underlying framework that makes it obvious. Without it, you're essentially flying completely blind into the exam hall.
Section 1. The Top Band Framework. Unlocking Examiner Perfect Answers.
Okay, let's break down the 4 vital steps of this top band framework. Step 1, identify the underlying physics concept. What law or principle are we actually testing here? Step 2, extract the evidence or data. You need to pull the exact numbers and units from the source. Step 3, apply scientific reasoning. This is where you connect that concept to your data using your formulas. And finally, Step 4, use examiner wording. Write your final answer using the exact, safe terminology and precision that the mark scheme demands. Concept, evidence, reasoning, wording. You absolutely need to memorize this sequence.
And here is exactly why this framework is so crucial. Look at the syllabus contents page. We've got chapters ranging all the way from forces and motion to thermal effects. The big takeaway here is that measurement, unit, and data rules aren't just isolated to Chapter 1. Not at all. They are hidden traps laid out throughout the entire exam. You're going to be penalized for inconsistent significant figures, whether you're calculating the momentum of a car in Section 2 or the specific heat capacity of a liquid in Section 5. It is everywhere.
Section 2. Interactive Challenge. Spot the fatal error.
Let's put this framework to the test right now. Take a really close look at this typical Cambridge-style practical data table. We've got a column for time and a column for temperature, with 3 rows of readings. At first glance, it kind of just looks like numbers going up, right? But apply the framework. Look at the data. What exact mistakes has the student made that are going to cost them immediate method marks? Pause and predict. Lock in your answer.
All right, did you catch them? First off, look at the headers, time and temperature. Okay, time in what? Seconds? Minutes? Years? Temperature in Celsius? Kelvin? The units are completely missing from the header, which is an immediate red flag. Second, look at the precision of the data. Time goes from 1.2, which is 2 significant figures, to 1.25,
which is 3, and temperature goes from 20 to 25.5 to 31.25. These are wildly inconsistent significant figures. A top band student would instantly recognize that the precision of your measuring instrument hasn't magically changed between readings. The data absolutely must be recorded to a consistent number of decimal places.
Spotting those errors is exactly what elite students do effortlessly. But to make sure you never submit a flawed table or calculation yourself, you've got to perform a mandatory routine before you even think about moving to the next question. I call this the final examiner check. It's exactly how you lock down your method marks permanently.
So here is your ultimate checklist. Before you turn that page, ask yourself, are the units actually included and correct? Are the significant figures consistent throughout your data, and do they match the least precise input? If there's a graph, is the scale accurate? Is it linear? And is it taking up more than half the page? Have you considered the uncertainty or anomalies in your readings? Have you safely identified your independent and dependent variables? And finally, and this is a big one, is the final answer reasonable? Like if you calculate the speed of a walking student to be 300 meters per second, you literally need to stop right there and recalculate.
Which brings us to the ultimate question. What actually happens when these foundational measurement rules collide with the hardest examiner report mistakes in the entire 0625 syllabus? Mastering units and significant figures, that's really just level 1 of your high-mark exam strategy. The real challenge is applying them to the most complex, high-penalty questions Cambridge is going to throw at you. So now you've got an unresolved problem. You know the basics, but you need to see exactly how they break down in advanced scenarios. You absolutely must speedrun the next skill. So to make sure you don't miss out on mastering those advanced skills, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Until next time, keep your units exact and your data bulletproof.